Hey folks, welcome to our 10.1 video on Taylor polynomials. We are officially starting chapter 10 now, and this will be our first section. We're going to break this video up into, we're going to break this section up into a few different videos just so we can really focus on what the patterns are that we're looking for in each one, and hopefully video one will help us understand video two, which will help us understand video three and kind of put all the pieces together. Okay, so this is definitely a big brain energy unit, but I know we can do it, so let's get started. All right, so skills to master in 10.1. Okay, we want to know how to find higher order derivatives. We want to be able to determine a Taylor polynomial at 0. We want to determine a Taylor polynomial at A, and we want to use a Taylor polynomial to approximate values in real-world applications. Okay? So in this video, we're going to focus on higher order derivatives. And to get us started, we're going to do a real quick warm-up, and then we're going to talk about what we're going to focus on in example 1 and example 2. Okay, so I leave myself a ton of room, but maybe we'll just squeeze it up here. Okay, so let's say we have a function f of x equals x to the 7th. Okay, and if we were to take a derivative, we would say f prime, we would use our power rule and we would get 7x to the 6th, right? Well, it turns out that we can do this process again, and sometimes we write this as f double prime, but we can also write this as f2 of x. And that little 2 means that we're finding the second derivative. And so in this case, we would use our power rule again, and we would get 7 times 6, which is 42, x to the 5th. Okay? And we could actually go again. We could find the f triple prime of x, or some might say f with a little 3 of x. And then we would bring the 5 down, so 42 times 5x to the 4th. Okay, so what we have squeezed in this little corner here is just our idea of what a higher order derivative is. All it means is that we can take more than just the first derivative, okay? Now, for this section, we're going to be using the little 2 and the little 3 instead of the double prime and the triple prime, okay? So whatever that little exponent is, that's going to tell us what number derivative we're on. So if it's like f with a little 7, that means that we found the 7th derivative, okay? All right, so as we take a look at these higher order derivatives, though, the name of the game here is I want us to, we're not going to simplify. Okay, so don't simplify. And then instead, we're going to look for patterns. Okay, now this is the same advice that I would give you on your homework assignments. For a question that looks like what we're going to do right now for example 1 and example 2, I don't want you to simplify. I just want us to look for patterns because the patterns are going to be more useful at the end of the day to answer the question. Okay? All right, so let's take a look at example number 1. It says find the nth derivative of the function f of x equals 1 over 1 plus x. Okay? Now, one clue that we really want to not simplify and instead look for the patterns is that I'm asking for the nth derivative. So I'm not asking for the 4th one or the 5th one, like a specific one. I'm asking us to find a pattern in general to find any derivative of this function. Okay? So here's what we're going to do. We're going to start by writing our function. Instead of writing it 1 over 1 plus x, we're going to write this as 1 plus x to the negative 1 power. Okay, so all we're doing is setting ourselves up to see what that power is so that we can use our power rule and kind of go from there. Okay, so f1 of x means we're finding our first derivative. So I can look at this and I'm already thinking I need to use chain rule. Okay, so I'm going to bring my power down. -1, parentheses, keep the inside the same. And then -1 minus 1 is -2. Okay. Times, I want to multiply by the derivative of the inside. So the derivative of 1 plus x is just 1. Okay. Now, I'm going to leave it like that for right now. And we'll see what we get. Okay. Let's move on to our second derivative, right? So we write this as f double prime, but we're going to start writing it as f with a little 2 up there. And what I'm going to do, I know times 1 doesn't change anything, right? So technically, I could have just written this -1 times 1 plus x to the -2. All right. Now I'm going to use my power rule again to take that second derivative. So I'm going to bring the -2 down to the front. Even though I know that -1 times -2 is 2, I'm going to write it as -1 times -2 times 1 plus x to the -3. All right. Now we do still have a times 1 for the derivative of the inside, but I don't have to write that because it's just times 1. Okay. All right. I'm going to do 2 more. So I'm going to find the third derivative and I'm going to find the fourth derivative. So f3 of x. All right, I got the -1 times the -2 times, this time I need to multiply by -3, 1 plus x to the -4. Okay, so I'm just bringing down the power and multiplying it because this is a constant. So I just keep it in the front using that constant multiple rule. All right, my f4 of x is -1 times -2 times -3 times -4 times 1 plus x to the -5. Okay. All right. So I want to pause for a moment. Now let's imagine that I asked you to find f of 9. I bet we could write out what we think it's going to be. Okay. So without actually doing it, let's see if we can find f9. In other words, the ninth derivative. Now, one thing we might have noticed is for the first derivative, I just had a -1. But for the second derivative, I had -1 times -2. And for the third derivative, I had -1 times -2 times -3. And for the fourth derivative, I had -1, -2, -3, -4. So I bet for the ninth derivative, it's going to be -1 times -2 times -3 times -4, -5 times -6 times -7 times -8 times -9. Seems like a reasonable guess based off of what we've seen. And then all of them have a 1 plus x to some power. Okay, 1 plus x. Now let's think about what that power is going to be. So for the first derivative, it was to the -2 power. For the second derivative, it was to the -3 power. For the third derivative, it was to the -4 power. And in the fourth derivative, it was to the -5 power. So if we're looking for the ninth derivative, it might make sense that it's going to be to the -10th power. Okay. So kind of cool that we can find all these derivatives, look for patterns, and then we can use those patterns to sort of think about what other higher derivatives might be without having to find every single one in between, okay? Now, let's do one better. What we're going to do now is we're going to take these derivatives and we're actually going to write them in a more clever way, okay? So before I show you how to write it in the clever way, there's one more thing I want to talk to you about, which is this idea of something called a factorial. Okay, so it turns out there's a concept called the factorial, and the symbol we use for that is an exclamation point. Okay, so your eyes are not tricking you. This is an exclamation point. And what it means is if I say like 3 exclamation point, that's really saying 3 factorial. And all that is 3 times 2 times 1, which will give us 6. Okay. Now, similarly, if I looked for 7 factorial, that would be 7 times 6 times 5 times 4 times 3 times 2 times 1, which is some big number. I don't know what it is, but we could put it into a calculator and find out. Okay. But anytime you have n factorial, that is going to be n times n minus 1 times n minus 2 times, and you keep going until you get to 1, okay? And this factorial just allows us to write something like 3 times 2 times 1 in a shorter way. Same thing, 7 times 6 times 5 times 4 times 3 times 2 times 1, we can just write as 7 factorial, okay? Okay, so now let's go back to our question and see how we might use this idea of factorial. All right. So here's what I see in the first one, okay? I'm actually going to factor out a -1 to the first power times 1 times 1 plus x to the -2. All right. Now, for the second derivative, I'm going to take a -1 out of the first term, and I'm going to take a -1 out of the second term. This is going to give me -1 squared times 2 times 1 times 1 plus x to the -3. Okay. How can I write that using our factorial? I can write -1 squared times 2 factorial times 1 plus x to the -3. Okay, well, for the third derivative, I can take a -1 out of the -1, a -2, and a -3. So in other words, I'm doing -1 to the third times 3 times 2 times 1 times 1 plus x to the -4. Or I can write this -1 to the third times 3 factorial times 1 plus x to the -4. Okay. All right. Can I do the same thing for the fourth derivative? Well, yeah, I can take out 1, 2, 3, 4 -1s. So -1 to the fourth. What's left is 4 times 3 times 2 times 1. 4 factorial, and then the 1 plus x to the -4. Okay, so it seems to be that we can actually go ahead and take these derivatives and create some sort of pattern with them. Okay, in fact, we've got everyone has a -1 to some power, right? -1 to the 2, -1 to the 3, -1 to the 4. And if I would do the ninth derivative, it would be -1 to the 9th. Okay. Now, every single one of them also has a factorial. So the fourth derivative has a 4 factorial. The third derivative has a 3 factorial. The second derivative has a 2 factorial, and the first derivative, 1, is really 1 factorial. Okay, so they've all got these factorials. Now, I bet once I take out all these copies of -1 in the ninth derivative, then I've got 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is just 9 factorial. Okay. All right. Now, they also all have 1 plus x. Oh gosh, this one, that's supposed to be to the 5th. Okay, so they all have 1 plus x to some power. We've got 1 plus x to the -2 for the first derivative, -3 for the second derivative, -4 for the third derivative, -5 for the fourth derivative, and this one should be -10 for the ninth derivative. Okay. All right, so we've done a lot of derivatives. I think we found the pattern. Now we're just going to use the letter n to talk about what number derivative we're on. So what do I mean by that? Fn of x, the nth derivative, will be -1 to the n power. And I know that because for the ninth derivative, I pulled out 9 copies of -1, whereas for the second derivative, I only pulled out 2 copies. Okay, so -1 to the n. Then I have n factorial because for the ninth derivative, I had 9 factorial. For the fourth derivative, I had 4 factorial, and so on and so forth. And then I've got 1 plus x, okay, to some power. So we've got our -1 to the n. We've got our n factorial. And the last bit will be, how do we come up with the power here? Okay, so 9, how do I go from 9 to -10? Well, I do n plus 1, right? 9 plus 1 is 10, but then I have to make the whole thing negative. Okay, so this is how we came up with the power for whatever derivative we're on. So let me put a box around this. This is our formula for how we find the nth derivative of this particular function, 1 over 1 plus x. Okay? So I know this was a super long example. I'm going to encourage you to take a look at example 2 on your own. All right, I'm going to go through it right now, but you can always come back later and check it over. Okay, so example number 2, find the nth derivative of the function f of x equals natural log x. Okay, so we're going to do the same thing we did before, which is go through a few derivatives, do not simplify, and let's look for the patterns. Okay, so f of x equals natural log x. That's our original function. Now, f prime of x is 1 over x. But we also know we can write that as x to the -1, okay? The reason why I might want to write it as x to the -1 is because I'm gonna keep finding derivatives. And so it's going to be really useful to know what that power is so that we can use power rule. So f2 of x will be -1x to the -2. F3 of x is -1 times -2, x to the -3. F4 of x is -1 times -2 times -3, x to the -4. And I'm going to ask you to try finding what you think F8 is, right? So like pick a higher derivative and think about if you have enough derivatives to help you come up with a pattern, okay? Now, I noticed that for the second derivative, I only have a -1, but for the third derivative, I have a -1 times -2, okay? So this to me suggests I'm going to have -1 times -2 times -3 times -4 times -5 times -6 times -7, but it's going to stop one earlier than my number. Okay. But all of them, let's look at their powers now. For the first derivative, it's to the power of -1. The third derivative is a power of -3. So I bet for the eighth derivative, it's going to be x to the power of -8. Okay, so the pattern here, not as gross as I think the other one was, but let's start using the idea of factorials and pulling out those negatives to see what we actually have. This time I'm going to start from the eighth one. I can pull out, let's see, 1, 2, 3, 4, 5, 6, 7 copies of -1. And then I'm left with 7 factorial, and then I have x to the -8. Okay, well, let's see what happens for the fourth derivative. How many copies of -1 can I pull out? 1, 2, 3. So -1 to the third. And then I'm left with 3 times 2 times 1, which is just 3 factorial. Then I have x to the -4. Okay, now for the third derivative, I'm pulling out 2 copies, and then I have 2 factorial and x to the -3. And for the second derivative, I have -1, only 1 copy, times 1 factorial times x to the -2. Okay, so are we ready to try writing this patterns with n's? Let's give it a try. Fn of x is -1 to the n minus 1, right? For the eighth derivative, I only had 7. For the third derivative, I only had 2 copies of -1. So it's not n, it's n minus 1, 1 less than that, okay? Then I take that n minus 1, and that's what I'm finding the factorial of, okay? Last but not least, I have x to the -n power. And this, okay, let's go back to our colors for a moment. -7, -3, -2, or 2 and 1. That's not a -3, that's a +3. All right, that's where this n minus 1 comes from. And then our n minus 1 factorial is over here. And lastly, the powers are exactly the negative of whatever derivative I'm on. Okay, so let me get that question on one page for you, but this is how we find the nth derivative of our function, right? So give those homework questions a try. Let me know if you have any questions.